In the dynamic world around us, understanding instantaneous change is crucial. This guide explores how limits in calculus provide a mathematical framework to handle these rapid transitions effectively. Limits describe how a function behaves as its input approaches a specific value. Imagine getting closer and closer to a destination. Limits help us grasp the behavior at that exact point. Think of a car stopping or an object launching into motion. These instant shifts are tough to capture, but with limits, we can analyze their behavior at that precise moment. Imagine a curve representing a function. The tangent line at a point on the curve gives its instantaneous slope, reflecting how it's changing precisely at that point. As we zoom in, the tangent aligns more closely with the curve. Enter derivatives. Derivatives let us find the rate of change of a function at an exact point. In practical terms, they're used to analyze motion, growth, and dynamic processes across various fields. If you want to know how something changes at an instant, first define the function. Next, pick the point of interest. Third, use limits to find the derivative. And finally, evaluate the derivative at the chosen point. Imagine tracking the position of an object with time using the function s of t. The derivative of this function, s prime of t, represents the object's instantaneous velocity at that moment. In a world of abrupt changes and swift transitions, limits provide the mathematical tools to understand, quantify, and predict instantaneous shifts. This makes calculus an indispensable ally in comprehending the dynamic nature of the world.